In the previous videos, we defined the derivative and how to take the derivative of some arbitrary function of x. So in this video, we're going to extend that idea to repeated differentiation and multiple derivatives. So f of x of a function is the value of that function at x. F prime of x is the derivative of f of x. It's the slope or the instantaneous slope of f of x at that particular location of x. But we can take the derivative of the derivative, and we can take the derivative of that derivative and continue that as long as we want. So f prime of x is defined as what we call the first derivative, d dx, and f double prime would be the second derivative, d squared dx squared, and that is the derivative of our derivative. So the second derivative gives us ideas about the curvature. It tells us how our slope is changing, so how our system is either, our function is either curving up or curving down. All right, so in order to do that, to evaluate a second derivative, we apply the derivative rules twice. So for example, if we want the second derivative of x to the n, well, we apply our derivative rules to x to the n, and we get nx to the n minus 1, according to the polynomial rule. So if we apply our derivative rules to nx times to the n minus 1, we are going to get n times n minus 1 x to the n minus 2. So that would be the second derivative of some arbitrary polynomial. If we want the second derivative of an exponential, the derivative of an exponential is an exponential. So taking the derivative again, we still just get e to the x back again. Okay, so e to the x again is a very nice function, and that its second and third and fourth and fifth derivatives are very simple to work with. What about sine and cosine? So d squared dx squared of sine of, let's say sine of kx. We'll use the chain rule on that one. So using the chain rule and the trig rule for the first one, we get that the derivative of sine kx is k cosine kx. Applying those rules again, derivative of cosine kx is minus k sine kx, so the result is minus k squared sine kx. And same thing for, well, let's still do a different color. All right, same thing for cosine. Second derivative of cosine of kx is the derivative of minus k sine kx. Derivative of sine kx is k cosine kx, so we get minus k squared cosine kx. All right, and then an example where we have to use the chain rule that's going to result in some more complicated results. We'll just use here. Second derivative of e to the minus x squared is equal to the derivative of, by the chain rule, this is going to be minus 2x e to the minus x squared. And then by the chain rule and the product rule, this is going to give us two terms. So the first, we take derivative of minus 2x, we get minus 2e to the minus x squared. And then derivative of e to the minus x squared is this, times minus 2x is going to give us, actually times 2, no, leave that there, plus 4x squared e to the minus x squared. All right, so that's the basics of how multiple differentiation works. So the second derivative gives us our first hint about curvature. Third derivative tells us how the curvature changes. So higher and higher derivatives gives us more and more functions about how the function is changing over time and in what ways the things are moving. So one relationship to physics that this has that we should take a note of is that if we have position x, which is defined as a function of time, then the velocity as a function of time is equal to the time derivative of x dx dt, and the acceleration as a function of time is how the velocity changes. So the acceleration is the second derivative of x, which is the first derivative of velocity. Also take note of all these examples here, because you will very likely perform all of these derivatives at some point in a physical chemistry homework set or test.